Hey guys, so welcome back. So we are here in the new class. This is gonna be another .NET obfuscation class, but this is gonna be actually pretty cool. I would say it is more advanced. So we have been dealing with a lot of this obfuscation, but in this case, it's gonna be something more like a multi-stage, and it's gonna be combining dnSpy, as we realized those very good features. But also, we're going to be dealing with the Son of Strike plugin with WinDBG, so that we can see the benefits there in certain scenarios. Okay, so a quick recap. Keep in mind that when we are dealing with this kind of deobfuscation stuff, so we need to keep in mind how reflection works, right? So a quick recap for you guys so that you can remember. So I'm just gonna open the assembly loader, okay, which is the code that we did here. Let me just go to the entry point. So quick recap, right, guys. So you remember that we have this assembly load or can be load, which is going to load a binary or a blob of bytes from disk, from resources, from the network. Then after that, it calls get type to get the class, or get types to get all the classes. Then create instance to instantiate that class, which eventually will call invoke member, which receives as a first argument the method to be called, the object that was instantiated, and any arguments. Okay, so this whole thing is very important for us because these are the indicators that we're going to be hunting for. Because at the end of the day, what we want to do here, guys, is by following our Carnita methodology, we really want to go quick and dump the second stage binary as soon as possible without spending time into the code, right? However, I'm going to be stepping into details just so that you guys know how to do a good analysis in .NET, but in a real scenario, we really want to go fast, okay? So let's do one thing first. I really want to run, one of the most famous tools when you are dealing with deobfuscation.net, okay? So the tool is called d for dot, right? And you pass it the assembly. Now, before running it, we are not teaching in Hack Defender to run tools, right? We are totally against tools. So we are teaching you how to do it manually, and eventually you're going to be the guy creating tools. Because what happens if this tool doesn't work? Or even if they work, I mean, you don't feel proud of running a tool and getting deobfuscated. I mean, when it is easy to do, go for it, definitely. But there will be cases like APTs that they are really good and they make sure that those tools are not going to work. And what are you going to do? Are you going to contact the creator of the tool and tell him, hey man, could you please update it because it's not working for me? I don't think so, right? So let's learn it, how to do it. So, but anyways, let me run it here quickly. You can see right away that it says that this is some sort of a .NET reactor. However, it gets an error and it doesn't do anything. It doesn't work. And this thing, man, is very common. So I just wanted to quickly check it with you that it's not working, and we don't care about that. That's why we're following our own strategy. Okay, so let's start opening up this assembly. Okay, so we go to our lab, double click, which is this guy. This guy, as you remember, and we already have. By the way, I do Control O here to show, Control O to maximize, which is just the far commands, right? So as you remember, we have this config file, which is going to tell us just run the framework version 4, which is the one we have. So, and that's something that we already explained in the previous classes. Okay, as usual here, we're going to do a quick view of the structure. We see that it has multiple resources. Those resources might be blob that eventually is going to be loaded and decrypted in memory, which gives us a good indicator that it might be the case. But you can see here, guys, it has now in this time, it has multiple namespaces. Within each namespace, it has classes, and within each class, like here, it has this guy doesn't have any method, but see, this class has this many method, and same for every single one here, right? So we can see that we have tons of namespaces, tons of classes, tons of methods, right? So it's gonna get dirty. And also we can see that these method names, namespace, classes, and method names are obfuscated. Obviously this was done with builders that are automatically generating this kind of obfuscation, right? So it's not easy to do it this time. So let's see how it goes. So we right click here, we go to the entry point. That way we just jump in, we don't need to find out where it is. And what we are going to be doing here, guys, we're going to be doing this dnSpy strategy in order to try to start debugging and eventually find the load or the create instance or the invoke member, any of those indicators that tell us that is about to dump, to load a binary from memory, and then we can dump it as we did before. Okay, so we're gonna put a breakpoint right here. I'm gonna run it. Okay, it runs. We wait a little bit, so we hit the breakpoint. And what I'm gonna do here, guys, is I'm gonna do F11 in order to step into the functions. And again, if I am doing it in real life, I'm gonna do F10 because I really wanna go fast. However, I just wanna get in to show you a specific obfuscation techniques. Okay, so I do F11 here. We can see that this function just returns a false, right? Then we go here, it returns true, then assigns a number to a value to num variable, which is 5. Here we can see that we have this call to enable visual styles. Those APIs or methods that are already seen, I don't want to step in because I don't want to debug library code. So for those cases, I do F10. And then we see that it sets the number to 1 because we are in a switch case of 6 values plus the default one. Okay, so I do F10. We get here again, it's gonna call the set compatible text rendering, another API that I don't want to debug. I do F10. Then here I don't know what it is, I do F11. And here is one of the things that I'm going to show you guys. You can see that we are getting into a function that is doing nothing. This is called junk code, which helps in the flow obfuscation, which basically means is that they want you to go in every single step doing nothing so that you can execute dozens, hundreds, or even thousands of instructions without any sense, and then eventually is not scalable for you to do it, right? So you need to give up. Anyways, we can go, it goes to this this label, which is go to IL1E. We go there, we get in, okay, again another function which is doing nothing, and then we go to go HC, which finally, guys, we get to the application run, which is actually the starting point. But as you can see, we were doing like 6 to 8 instructions with no sense before jumping here, which is exactly the purpose of the control flow obfuscation. Okay, so now I'm gonna do F11. I get in. So now we get into another loop of another switch case, which now we have around 5 cases in this section. Okay, so we'll go inside again, junk function. We get a number 4, and you can see these guys, this is nothing, but they just insert it and then they actually just put number 4, so it's just junk. Okay, so we get here, we don't know what it is, so you step into, nothing here, so you can see nothing here. So you can see that this function does nothing and actually went down 2 paths. Okay, then we go here, it returns false, and we can go in, right? Number 3, then it goes to this case, we get there, it's a CTOR, I do F10, I don't want to debug it, F11, then we get into the break goes to ILAB, we go there, then from here we get in, and now we get into another section which has now another switch case, which in this case has now, see, it's like 22 plus the default cases, and this is the third switch case we just get, you know, in 1 minute. So it's crazy. Anyways, we can go in. So we get to that data grid view. I don't wanna debug it. I do F10 to step over. Then we get number 17. We get here, and why we get here? Because if we go to number 17 up, we can see that it is a break. That's why we reach here, right? But the debugger just jumped right away. Okay, then it says begin init. I don't want to debug it. F10, then F11, number 0. Number 0 is gonna get into this guy. It says suspend layout, F10. I don't want to debug it. Number 9, then 9 goes to return false. Then it goes inside this guy, which basically reached case 9. We get in with F11. It says something order columns, F10 to step over, F11, number 15. Number 15 just jump here. Let's see what happened with number 15. It is a go to ILVE. That's why we are here, right? And here is gonna do some data grid view. I'm gonna do F10 because I don't want to step in. Number 3, we get here with the doc style again, F10. Number 13, and you see, guys, it's kind of getting tedious, right? We only have 2 minutes and 3 minutes, and it's getting tedious. We're not heading anywhere. But as a suggestion, try to run it for 1 hour. Try to see if you get something in 1 hour. If you don't get anything, you need to find another strategy. I do F10 because this is calling new point. Then we get to num A. From num A, we get here. I do F11. And see, it looks like it's running, but eventually we will realize that it's not running. It's actually decompiling the next chunk, dnSpy. And the reason it's taking too much time is because it's getting a huge new block. And guess what, guys? We get it into a new switch case. You remember the previous switch cases? It was like 4 switch cases already. And now let's see here, guys. We have a new switch case. The last one was 22. Let's see this one. I want to save you time. Don't be scared. So we are so far 340 switch cases, guys. Eventually, we get into 426 switch cases. And be my guest, you know, at this point, it's like, man, this is totally obfuscated. We need to find a different way to deal with this, okay? So here is when Son of a Strike sauce plugin from WinDBG come into play. What we can do now is following a different strategy. What we can do is we can run this binary in WinDBG, and then we can set breakpoints on methods that we know are going to be called if you want to load a binary, like assembly.load, and check if we can get a breakpoint right away without dealing with this whole shit. Okay, so let's do that. So we open here WinDBG, okay, and then I'm going to open the same binary here. Okay, I open it up. Then I'm gonna load my workspace. In WinDBG, you can have these windows configured. So for example, you have that window. You might wanna have here, let's say this disassembly window, and put it here, and put it, I don't know, in the right side or wherever, you know, wherever you wanna put it. And then you can have the layout wherever you want. Once you have it, you just save it. You set save workspace as, and you save it. It's going to be saved in the registry. And then if you want to move this same view of your layout, you just export the registry into a new machine, and you have your layout everywhere. Okay, in my case, I already have my workspace, which I called Danux small. So when I run it, you can see that I have the proper layout already. Okay, so now what we are gonna do here, guys, is that we're gonna set up the source environment. But before going there, you need to make sure that you have your symbol file path properly set. This is a standard syntax that you can put in order to have the proper symbols, so that you can see symbols in the code and you can have more idea of what's going on. Otherwise, it's going to be very hard for you to see just addresses and names, right? Weird names. Okay, so now let's start with loading the assembly and the breakpoints. At this point, we open the assembly. However, if you remember our class of obfuscators and packers, at the beginning, we talk about, and also in the Windows binary class, we talk about how this whole CLR works. So the first thing that is going to be loaded is the CLR engine. The CLR engine is going to load the just-in-time debugger, and the just-in-time debugger is going to compile at runtime the methods being used on demand. In other words, if you have a method called create address, let's say, if that method is not called, it's not going to happen anything. But as soon as that method create address is being executed, CLR send it to JIT. JIT, the just-in-time debugger, is going to compile it at runtime, generate the native code for it, and execute it. The beauty of the SOS plugin is that it's going to allow us to set breakpoints. So as soon as we see this manage code create address function being changed into native code, it's going to put a breakpoint. So in other words, we have visibility of the managed code into the native code so that we can debug it. Okay. Now, there is one important thing here, guys. Before we put breakpoints, we need to make sure that the library or assembly where those methods belongs to is loaded in memory. Otherwise, when you put the breakpoint, it's never going to hit. Let me explain you what I'm trying to say. Here, I'm going to run the SXELD CLR. What I'm telling here WinDBG is, hey, you're going to run with the Go, but with the Go instruction. And as soon as you see the CLR engine loaded, stop. Okay, so we run it. It says, okay, I load these multiple DLLs, and eventually I saw the CLR, so I stop. Okay, that allows us to run all the way where CLR is loaded, but before running the malware or the binary. Now, at this point, what I'm going to do is I'm going to load the SOS plugin. Okay, so the SOS plugin, it normally is in a default path. You know, if you didn't do anything with the path, you will find it there. Oh, sorry, let me just go to Microsoft, then you go to framework, okay, and then here you will have multiple versions, whatever versions of .NET framework you have installed. But in my case, I am using the version number 4. That's why I go to version number 4 here. Okay, and if we do a dir here, we can see that here is our DLL, which is the Son of a Strike plugin that we are going to be loaded into the WinDBG. Okay. Now, there are many ways to load it, but the most recommended one is to put the full path so that you know exactly what is the source version that you're loading. So what we do here, guys, is that we do there's a command that is called load, load, and then basically you pass the path, okay, /source.dll. Okay, now how do we know if this guy is now running? We basically need to start executing source related commands. Okay, so one of our first commands is called bpmd, which allow us to set breakpoints into the managed code.